Hello, everyone. Good morning, afternoon, evening. Dear authors and invited guests, welcome to Technical Session 5B. Myself, Priyanshi Goyal, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 10th International Conference on Information and Communication Technology for Competitive Strategies, ICTCS 2025, Jaipur, India. The 10th edition of the conference is being organized in a hybrid mode. Just a second. The physical event was held yesterday in Jaipur, India, and the virtual event is being held through Zoom today and tomorrow, that is 16th and 17th of December 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentation and 2 minutes for question and answers. On 9 minutes, I'll raise a gentle reminder. I request all the participants to kindly adhere to the timeline so that we can conclude the session within the time frame. There's another request to all the participants that you all stay connected with us till the closing remarks. If you have any queries or updates, then you can write it to me in chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Bindya Jain. Dr. Bindya Jain is an associate professor in the Faculty of Computer Science and Engineering at Purnima University in Jaipur, India. Her research interests are generative AI, green AI, human machine interaction, and IoT, contributing to research and faculty development programs, and is recognized for her work in computer science. Thank you so much, ma'am, for joining us today. I would like to request you to share a few words of welcome to the participants before we commence the session officially.
Thank you, ma'am. Thank you so much.
Yes. All right. Can we commence the session?
Yeah, sure, ma'am, you can.
All right. Thank you, ma'am. So without further ado, I would like to request Sir Prajwal Kumar to kindly present his paper titled 5G NR Physical Layer Modeling using MAT Lab. Do we have you here with us, sir?
Yes, ma'am, I'm here.
All right. Can you please share your screen?
Okay, ma'am. Okay, ma'am. Good afternoon to everyone, ma'am. I am Prajwal Kumar. I am Prajwal Kumar. I am from Kelly Technological University, Hubli. Now I am presenting the my project work on 5G and physical layer modeling using MATLAB under the guidance of Sunita Budiyal and Amit Tilgal. My problem statement is the implementation of 5G and our technology demands on the tools and robust tools and technology for the simulating performance. Evaluating the project aims to develop the 5G link level simulation to access the physical layer techniques under the various channel conditions like analyzing metrics like throughput and VLR, like this, ma'am. Our main we are our objectives, ma'am. We are divided into six objectives, ma'am. One, developing a 5G and link layer simulation, and another one is evaluating the physical layer techniques and the simulate the various channel conditions. In that develop of the 5G and link layer simulation, we use implemented on the MATLAB simulation, compiling the 3GPP. The 3GPP means a third generation partnership project, ma'am. We done that, providing the flexible control over the different physical layer and configuration. And another our objective is evaluating the physical layer technique use, analyzing the different modulation coding schemes like the QPSK and QAM up to 256 QAM, and using the also channel coding like LDPC and polar coding. And the our third objective is simulate the various channel condition like TDL and CDL, cluster delay and time delay. And another three are the measuring the key performance metrics, optimizing resource allocation, and validate simulation result. These are our three objectives. Our main motivation is the need the flexibility simulation tool. In MATLAB, we can using the 5G toolbox, we can flexibly simulate our project. And another one is performance optimization. In performance, yeah, custom simulator allows the analyzing of the critical metrics like throughput, latency, and BLR and BER are the main optimization of the 5G link layer performance. And another one is support of the advanced technique use. We are using the advanced technical modulation schemes like QPSK, coding techniques like the LDPC and polar codings, and adaptive modulation, ARC. These are our advanced technologies. And the research and development. It provides the foundational academic research of the industrial protocols. Industrial protocols means 3GPP protocols we are using in this project. And these are the main techniques we have used. Channel modulation schemes like QPSK. QPSK to 256 QAM. And that is the channel coding. Channel coding. In this channel coding, we are used the two channel coding. One LDPC for data channel, another one is polar coding for control channel. And the multiple axis, OFDM downlink, orthogonal frequency multiplex axis, and CCFDM uplink enhance efficiency we are using, ma'am. And the MIMO and beamforming in 5G MIMO support up to 256 array of antenna, and also beamforming used in this project. And the channel estimation and equalization, these are, and waveform, arc, and resource allocation. Rest of us we use them. The main 5G and architecture, ma'am. In this we can see that UV, GNB, AMF, SMF, and UDP. UV is UV first carries the signal from user to base station, and AMF and SMF as functions to allocate scheduling, IP addressing like this. AMF means AMM that means access mobility management function, and UMF means user plane functions. This UMF main purpose to forwarding the data to flow the data packets, and rest N6 is connected to internet. To using the overall we can communicate with UEs. This is the main architecture of 5G. We done the taken the majorly four research paper. Methodology, we have used 6 methodology. First, we using the MATLAB platform. We in the MATLAB platform we use the MATLAB 5G toolbox, transmitting and receiving the GNB and UVA signals, ma'am. And second one is the system design architecture.
This is a 9 minutes reminder. Kindly complete in 1 minute.
Okay. These are the methodology I use: MIMO, receiving full flow work, channel conditions. These are the transmission block, ma'am. This is a receiving block, ma'am. We have used the two scenarios, where one scenario is with the high quality high SNR, and CQI, high CQI. Each CQI we have used a different CQIs, QPSK to 250 PSK. And also we using one without the arc, one this is a with arc. This is a throughput performance. In that we can see that the our main black dot is, shows the practical value, and the other shows the theoretical. This shows the dot shows the theoretical value, and the under one shows that QPSK 16, QPSK 60, 64 or 256 are the real life outputs. This with HARC. Using the HARC means hybrid automatic retransmission queue. This enables retransmit the signal until it's reliable and robust. This project concludes that enabling the AMC adaptive modulation coding and ARC significantly improves our throughput in real reliability of the 5G downlink physical layer. This shows the in both the scenarios we can use the high quality assessing our needs and specification. We can also use the low quality for robust and reliability. These are the future scope. Designing the we can also design the upcoming waves and improve the using this simulation, customizing the 5G solution for the rural connectivity and IoT. Like this is used for the network slicing also. This we have done a simulator that can be helped for future waves and IoT device like network slicing. Okay, ma'am. Thank you.
Okay, you are Prajwal Kumar.
Yes, ma'am.
Okay, Prajwal, can you please come on a first slide of your title of your paper? Yes, 5G and a physical layer modeling with MATLAB. So what exactly you are four participants are there? What exactly your work on in this paper?
Ma'am, in this paper we have done a simulator for the physical layer modeling, ma'am. Using
Okay,
a two condition, ma'am. One with the arc without one with arc, another is without arc, and we are doing that comparison both with arc without arc for the different scenarios and conditions like that.
and you are using MATLAB also.
Ma'am, in the MATLAB we have the we can have access of 5G toolbox, ma'am. Real life scenarios like 5G waves, how they react, and other
Show
things are
me
there
the.
in MATLAB 5G tool,
Yeah.
ma'am.
Okay, some sort of MATLAB equations or calculations which you are doing. Can you show me?
No, I don't have that, ma'am. Only I have PPT, ma'am.
Okay, you are not showing that data what you are done, but I'll just suggest you some sort of datas and the value calculations you have to add in your PPT so that it will be better for understanding what exactly you are doing in your part. Okay, and yes, next method, come on methodology part. Simulation, SAD, transmitter workflow. Yes. And what exactly the meaning of a transmitter workflow? What you are doing in that particular scenario?
Transmitter workflow, ma'am. Uh, First, we are generating a 20,000 TB, ma'am. Transmission block, ma'am, for transmission. For that,
And
we are generating from GNB to UMM, means base stations to user equipments.
how it will be collected? These
Ma'am,
transmissions?
MATLAB, MATLAB toolbox is provides that data, ma'am. We generating that using the
Can
base
you show?
station.
Have you explained this in your paper? That
Yes,
how the transmission will be captured with the help of MATLAB boxes
yes, ma'am. I mentioned.
mentioned.
Yes, ma'am. For the time limitation, I have only added some important points only, ma'am.
Yeah, but some of the part you have to add in your PPT, so it will be better clarification of your work.
Okay.
Okay. Yeah, ma'am, please next.
Thank you, ma'am. Moving forward, I would like to invite uh, Sir Jogi Gaghari to kindly present his paper titled A Review of Data Collection Technique in a Existing Scenario for Marine ROV. Do we have you here with us, sir?
Yes, ma'am. A very good afternoon to the ma'am and the panelist. I hope my voice is audible. I
Yes,
would
you're
like to
audible. Can
add,
you please share your screen?
yes, I hope my screen is visible.
Not yet.
Just, I hope,
You stopped sharing.
just a second.
Yes, your screen is visible. Can you please put it in slideshow mode?
Yes, yes, sure, ma'am. Very good afternoon, everyone. My topic of presentation is a review of data collection technique in an existing scenario for marine ROVs, remotely operated vehicle. So I just briefly start with some introduction and literature review. Uh, See, our current world is facing the industry fourth industrial revolution, where the robotic is one of the crucial part, where mechanical, electrical, and computer combinations has been implemented for the upcoming specialized task. The marine environment represents a challenging framework for the exploring of cutting-edge automation related to metallurgy technologies, where the Earth is covering 70% of the underwater structures and marine structures, where we have just explored 5 to 7% of the underwater structures. The marine robot is a type of the robot technology who works underwater or on the surface of the water. The marine robot has grown from the nascent navigation and control algorithms for the underwater structure vehicles. The powered autonomous underwater vehicle routinely able to dive on maximum under to 6,000 meters. There is a current worldwide interest in the developing of the new tools to support the exploration, observation, sampling, and precision monitoring of the marine environments. There are few structures available for the same, namely as a UUV, unmanned underwater vehicles, ROV, remotely operated underwater vehicle, AOV, autonomous underwater vehicle, USV, unmanned surface vehicles. ROV is low speed box vehicle which works fully actuated where mainly used in inspection and intervention of applications. AOV is high speed flight vehicle. It is under actuated where mainly used in a mapping and surveying applications. We'll like to glimpse on the some of the literature reviews. In the literature study, in the recent years, the marine robots has significantly advanced in recognizing how the data is collected in oceanography research and monitoring. Traditionally, marine data collection methods include the ship-based surveys and stationary sensors face challenges such as the high costing, limitation specific costing, and the environmental risk. The emergence of the autonomous robotic system has provided the more efficient safety and the cost-effective alternative for the marine data acquisitions. The marine robotics has revolutionized oceanographic research and monitoring. The limitation of the traditional methods which we have seen till now was a high operational cost, limited spatial coverage, environmental, and the safety risk. Autonomous robot system provides the cost-effective and safety acquisition, wider and continuous ocean observations. More adding into this, there are few detailed structures which was being observed where AUV, which we justly previously discussed in the introduction, has modular, lightweight, and longer endurance designs used for the ecological monitoring and seabed mapping and environmental studies, collect temperature, salinity, chemical and biological eDNA data for the same. Remotely operated vehicles, human control mainly, system for the complex underwater task equipped with a robotic arm, maybe sometime yes, no, sometime not. HD cameras and sensors are implemented for the data applied in the core reef studies and the infrastructure inspections. Unmanned surface vehicle where can has recently seen the solar powered and suitable for the long duration missions used for the methodological monitoring, water quality analysis, and the communication relays. In AI, artificial intelligence, enable adaptive mission planning and reliable time discussion making and improves efficiency and reliable collection, which was being seen in the literature details. The Swan robot has emerged in a multiple robot and coordination to cover the large areas, enhance the resilience, and the reduce redundancy in the missions. If we focus on the data collection technique, there are six sensors technology has been used till now. The first is acoustic sensors, which is one of the backbone for the underwater structures. Uh, where the data collection is one of the important part. Multi-beam sonar for the bathymetric mapping for within tolerances of plus or minus 0.1 accuracy. At the depth of the 1000 meter, AI-based error correction enhanced resolution was being implemented here. Operational sensors, the water quality monitoring, where the measure the turbidity and water quality of plus or minus 2% precision was being there. AI algorithm improves the image processing in the low visibility conditions. The chemical sensors, the high resolution pH and dissolve oxygen measures plus or minus 0.01 HP accuracy was being seen. Biological sensors, where specific identification with 99.9% accuracy across 1000 taxa, no inhabited biodiversity and monitoring and conservation planning was it. Imaging sensor, sea floor image at the C4 image at 1 mm by pixel, precision down to the 6,000 depth was being seen. Unless with ROS2 for the autonomous navigation. ROS2 is also known as a Robot Operational System 2 and NTU, which we have seen here in the details, were named as a nephological turbidity unit segments. If we move ahead to the analytical methods, the analytical is the intelligence layers in the marine robotic and environmental monitoring. The growth of the IOV. IOV is Internet of Underwater Things, robotic platforms, and AI enable shifts focus on the data collection to the interpretations. If we focus directly on the table, AI and AI algorithm and big data analysis, the major structures upcoming years enable the platform recognizing anomaly detection and the predictive modeling applied in a biodiversity assessment. Ecosystem and change and detection and security monitoring was also being seen with the cloud platform. Big data analysis handles the massive data sets from the distributed sensor supported mapping, pollution tracking, and the real-time monitoring and the cloud-based systems are being seen. More addingly, quantum computing, digitization frameworks, and satellite with 5G structures was also being seen in such kind of platforms. If we move ahead with the key challenges, was the underwater communication constraints, navigation, localization limitations, energy management and sustainability, environmental degradation of the system, and interoperability and standardization issues was mainly seen. Where if we narrow down these particular points, the equating communication with the radio frequency was not being used in these platforms. Low bandwidth and high literacy, limited real-time control and data exchange, navigation and localization limitation, no GPS underwater, initial and aquatic navigation, collective localization drifts, energy management sustainability, limited recharging operation, effective population and needs, ultra low power electronic was being seen in energy management sustainability. If we for the mission-based structures, environmental degradation of the
This is a
systems.
gentle 9 minutes reminder.
Sure, we're just about to conclude. Biofueling and corrosions and sensor and degradation and adaptive maintenance and the needs. Interoperability and standardization issues, property protocols, limited platforms integrations, and reduce the data sharing. If we move further the observations, these are the MLA integrations. Cooperative swan robots were also being used for the observation somewhere, not in the widely used. Modular marine robot system were also being seen. Sustainable long range monitoring were also being covered somewhere in if there are few challenges in such areas. If we conclude on the last point, the marine robot had transformed the ocean data collection, enabling operation in the deep and hazardous environment. AUVs, ROVs, USVs provides a capability beyond the traditional in the suit and remotely controlled methods. The growing global demand of the environmental monitoring, climate research, and resource management is driving further adoptions. The key engineering challenges the limited underwater ecosystem communication bandwidth and the high latency. The lack of the GPS underwater requires alternative navigation and localizing methods. Energy constraints, limited mission duration, the sensors and the system degradation due to the biofueling and the corrosion and the mechanical wears. The current research trend focuses on the AI ML for the autonomous navigation, adaptive mission planning, and real-time discussions making. Cooperative and swan robots to improve the spatial coverage and the redundancy and the data fusion. The modular robot platform with common communication standard for the interoperability and scalability. The advance in sensor technology, optical, acoustic, chemical, biological, enable the multidisciplinary ocean data collection was being left. The marine robotics
Sir, I
supports
request
projects.
you to kindly conclude at the earliest. You've already crossed the 10 minutes mark.
There's just two lines, ma'am. The further progress depends on the strong interdisciplinary collaboration, improves the communication, energy management, and the long duration autonomous, ethnic, and responsible deployments. And the marine robot has significantly advanced the ocean science with the play of the critical exploration, understanding, and protection of the marine ecological systems. Thank you, ma'am.
Thank you.
Yes,
Are there
ma'am.
any questions?
Yes.
Yes,
Uh,
ma'am.
Yes, ma'am.
Come on first slide, the title of the presentation.
Yes, ma'am.
Okay, what exactly your work over there? As I seen in your presentation, you are just exploring what the meaning of your work, like the way you are doing. Only explanation part of there, what the things are there. But what exactly your work, what you are doing in your paper, can you differentiate them? That
This is one of the review papers, ma'am, of my one of the topic is developing underwater robot,
how
which
much
is
papers you are review?
this is my first paper for the review.
Okay, no, how much paper you are?
For the
Uh,
total reviews, it is around 48 papers it was being taken for this particular review, uh, but for only to focus on the data collection techniques.
okay, okay, fine. You are like telling 42 papers you are reviewing. Okay, come on, reference part of your presentation. Yes, You don't think so? You are using 2018 and right now it is 2025. You are using
So
like previous year
this is
papers. Is it a
yes,
current
yes, ma'am.
study? Is
Yes, ma'am.
are
There
you
are
think these are the current study?
Ma'am, it was being considered. A few papers, if even I have mentioned in my presentation, if we see the tabular forms, if I what data I've taken, it is on 21st, 23, and 22 was also being considered. Even the
Because
few of the 23 which was available on the platform.
but as you see how much the robotic works are done with the help of AI, and you are talking about the marine era. So lot of work is there already done.
What the same category which I was exploring, I have all the papers I have considered. 42 papers was only part of this paper.
Hmm.
Other paper is a general
But
review also being there, where also I have considered more 30 to 42 papers in the same category. So this paper is only dedicated for the data collection procedures and the scenario current.
I
Yes,
suppose you
ma'am.
have to add new papers also because the data collection techniques are definitely changed, and they are all these techniques are also refined by various methods because AI sensor, IoT sensor devices are there. So most of the part of data collecting work will be done by the uh, devices. So you have to add on this. Okay, fine.
Sure,
Thank you.
sure, ma'am. Sure. Thank you. Thank you, ma'am.
Thank you, ma'am.
Should I off the screen and left?
Yes.
Yes.
Moving forward, I would like to request Ma'am Mrunal Savde to kindly present her paper titled AI in HR Development, Reskilling Practices for Sustainable Talent Management for Achieving SDG 8. Ma'am, do we have you here with us?
Yes. Good afternoon, everyone. Can you hear me?
Yes, I can hear you.
Just give me a second.
Yes.
Can you see my screen as well?
Yes, your screen is visible. You may start.
Okay. So, good afternoon, everyone. My name is Mrinal. I am a PhD scholar at Symbiosis Dean University. And this is the first time I'm presenting into the international conference, and I'm very happy about it. Thank you for the opportunity. My topic is AI in HR development, reskilling practices and sustainable talent management for achieving SDG. So, here three components are combined together. One is artificial intelligence, second is HR development, that is reskilling, and third is SDG, that is sustainable development goal 8, that is decent work and economic growth. So normally, what happened is the background for this study is very simple. In today's rapidly changing world, we all know that we are using artificial intelligence in all fields, and in human resources also, artificial intelligence is getting imbibed in all the streams. But it has been observed that reskilling practices are not that much using AI techniques. This is the first problem. The second problem is we all, as a world, trying to achieve the Sustainable Development Goal in 2030, in which the SDG 8 is decent work and economical growth, wherein we want people to have very good jobs, we want people to have fair wages, and we want people to have good job satisfaction. For that, if we use AI in the HR techniques and AI for reskilling, the people would be ready for tomorrow, and people would be ready for, for having good job and having decent work environment. So this is the rationale of this work. So as I explained the background, I want to study how artificial intelligence helps to reskill the people in a way that they would be ready for tomorrow. I want for this study, I have utilized secondary data and primary data as well. But the primary data is limited, wherein I have collected a lot of data from the international organizations and the HR records. Of course, my guide helped me a lot in it because I was a new person to it, and she helped me to explore the data. For primary data, we have used Delphi method. Delphi method is actually the primary interviews that we have conducted from the experts, And we have taken their open-ended interview where we understood what are their opinion about these subjects. Because this study is new and there would be some guidance would be provided further, but whatever we observe that there has been a positive impact of integrating artificial intelligence into decent work. So, introduction is why we need this study, because there are the AI intimation is very important into the HR practices, and we need problem solving and IT and analytical skills. We need to create future ready workforce through AI based training. We need AI to have strategic thinking, data driven insights, and performance optimization. When we all see SDG 8, I want to tell what is SDG 8 to a person who does not understand anything about it. SDGs are for future. We want to achieve sustained and inclusive economical growth by promoting productive employment, technological advancement, fair wages, safe and dignified working condition for every person who's working today. We have AI-based talent management in SDG 8. Which SDG? See, SDG 8 is a very vast topic, but I have taken three topics in SDG 8. One is sustained economical growth, second is higher productivity through technology, and third is reducing youth unemployment via skill training. Why these three? Because I think that these three will be impacted a lot with the AI integration into HR practices. So, AI-driven upskilling promotes innovation and productivity. It supports fair, efficient, and sustainable labor practices, and it helps through different AI tools. So, objectives are very clear. We want to make sure that when we integrate the AI talent management process, how SDG 8 impacts. We want to make sure that when we integrate AI in reskilling, how it helps in decent work and economical growth. And we also want to understand that is there any impactful growth, or is there only something that is, integrated as a concepts. So scope is very limited. As we all know, SDG 8 is a very vast subject. HR reskilling is also very vast subject, and AI is also very vast subject. So I don't want to go into a detailed approach, but I want to go into a specific approach. So when I say SDG 8, I want to see only 8.1, 2, and 3. And when I see data, I have collected only secondary data from some resources. And for primary data, I have taken only few experts, which are collected through Delphi method. For artificial intelligence, I have only taken AI analytics, feedback monitoring, chatbot and adaptive learning, and machine learning. Of course, there are many AI techniques available in the market, which would be useful for this process, and I'll integrate that in the later phase of my research. But right now, I am only integrating AI analytics, feedback monitoring, chatbot, and adaptive learning. Statement is very simple. AI is growing in all the technologies. We want to make sure that it is also implemented in talent. It is already implemented in talent acquisition and performance evaluation. But in reskilling, it has not been implemented the way it should have been. We have to make sure that its impact on the reskilling process has been studied, and we have to make sure that that bridge will help us to understand how it impact on SDG 8, that is decent work and economical growth. These are the theories that have helped me. I have also taken some theoretical framework from the already established authors, but these are the theories that has been given by great scientists, and these theories are helping me to understand my study better. So human capital theory talk about how investment in education and training of a person improves the future of the person. And I implement it as if the training has been implemented in my AI, it will create a decent work for all the people. Technological acceptance model is acceptance of any technology depend on two perception of any person. One is how important is the technology, and second is how easy to use the technology. See, as AI is something that we are already using in all our aspects, it is easy to use, and training with the AI will improve the productivity of employees, make create a decent environment for them. Human-centered AI is a very interesting theory. And why it's interesting? Because we all are using it in our phone, we are all using in our life. So this theory will help us to design an AI-based training and reskilling technique where people will not get bored with the regular tasks and regular techniques that they are doing on everyday basis. Future of works theory. See, future of work theories is a very new theory. It's 2017 theory where it says that work of every person will change based on economical, social, and technological growth happening in our country or happening in the world. This tells us how artificial intelligence is also important in performance of employees and reskilling of employees, and how it will help us to improve in SDGs. Now, literature review. This is the literature review. I'm not going to read it. This is the literature review is based on all the authors who are already working in this organizations. I have studied almost 12 to 15 papers based on it, and also I will increase the scope to understand that how people are already adopting these technologies in different business functions and how it's helping them to grow. So this is like four theories here. I have included more in the paper, but I have included very few into this presentation. Now, research methodology. Research methodology includes three things. One is I have collected the secondary data from two resources. One is from already published resources of public companies like, public organizations like ILO or any other organization that are working into this domain. And second is I have collected the data from HR managers whom I had interaction related to this, whose companies are already adopting these technologies in HR processes. Second is I have taken Delphi method. Delphi method is I have taken opinions from all the decision makers who are already working into this domain. And second is I have compared how traditional reskilling is and how AI-based reskilling is, and how the comparison helps us to understand how to achieve the SDG 8. So see, Delphi method, I have taken 15 experts. Of course, I could have taken more, but I wanted to have a specific and narrow view. So I have taken the people who are already working in this field because this is a very new field. So it includes 6 HR professionals. They had a good experience working in AI and HR, law experts and AI experts. So 5 law experts who are making the policy and who know how to integrate it, and 4 AI experts who are using AI technologies and they are IT engineers. And then when I collected all the opinions, I have made sure that these opinions are integrated, and I have made a data wherein I can show how integration of AI into the reskilling process impact on SDG. This is the evaluation of secondary data. So secondary data is collected from two things. One is a human capital
This is a
index
gentle
published by.
9 minutes reminder.
Okay. Human Capital Index Learning UNDP report. This is something that my guide helped me. And another thing is I have taken reports from the public domain. This is the conceptual model wherein I tell where after reskilling, after integration of AI and reskilling, how people are very productive. And these are the number of the results of the study wherein I can show that how things change after integration of AI. So you can see that when 40% is converted into 72, everything is increasing based on the impact of AI in SDG. This is the same. I can see only three things because the time is limited. Economical growth has been increased by 89%. Decent work has been increased by 55%. Enhanced economical efficiency is increased by 34%, which was my aim while doing this study. This is my discussion and conclusion, which only says one thing, that when you implement AI into reskilling process, it impacts very positively and it will help us to achieve decent work and economical growth. Thank you so much.
Thank you, ma'am. Are there any questions?
Okay, Mrinal, you are talking about that you are collecting some, you are using secondary data as well as primary data also. So
Yes.
what is the exact medium you are use for collecting a primary data? Any questionnaire you are creating, or any which sort of medium you are using?
Ma'am, I have created an interview, open-ended interview process, which is the where I have collected some question. I made a structured questionnaire, but it is not a close-ended. I have made it open-ended so that they can give their opinion freely, and we can make a inference whether it's impacting positively or negatively. So it's a
Okay,
structured interview process.
okay, and who are the persons those interview you are taken?
I have taken
Academician
15.
or? academician or any other? Those are HR based or any other?
Ma'am, I have taken two companies which are already implementing AI into their HR processes. In those 15, I have taken six HR managers, five law policy makers which are actually implementing them, and four AI
No, I'm asking
experts.
about the open-ended questionnaire, which
Yes, ma'am.
open-ended questions you are asking. I'm asking
Yes.
who they are.
Yeah, they are the HR professionals of a company, ma'am, who is already implementing this.
Okay,
Yeah.
implementing this. Okay, fine. Can you please explain Delphi method one more time?
Yes.
And what
So,
sort of your work in this? Because Delphi method is a already uh, one of the method which is used. Okay,
yes.
as your part, as your contribution, what you are doing?
Yes. So, as a new researchers, I have formed a structure interview related to the Delphi method. This structure interview is open-ended questions. I have taken help from my guide and I have made an open-ended questionnaire. And I have sent the invites to all these people on the LinkedIn, and I have connected with them, and I have given them questionnaire. I collected the questionnaire answers from them, and then we filled it with the thematic analysis, wherein if they answer very good about it, it's ranked as one. If they have given a little, middle answer, I have ranked it as a two. And after that, completing it 1, 2, 3, we have done a thematic analysis based on graphs. And those graphs are included into the studies. But it is not included here, but it is included in the paper.
So you can say questionnaire based.
Yes.
Like primary data you are collecting. Okay, fine.
Yes. Thank you, ma'am.
Thank you,
Okay,
ma'am.
next please, ma'am. Yeah.
Yeah. Thank you. Should I stop sharing? Okay. Thank you.
Thank you. Moving forward, I would like to request Sir Pushkar Pandit to kindly present his paper titled Automatic Tablet Dispenser and Notification System Using Microcontrollers. Do we have you here with us, sir?
Yes, ma'am, I'm here. Am I audible correctly?
Yes, you're audible. Can you please share your screen?
So, hello, ma'am. Hello, everyone. My name is Pushkar Pandit. This is my first time presenting a paper in an international conference. So, thank you for this wonderful opportunity. Good afternoon, everyone. Today, I'll be presenting my paper titled Automatic Tablet Dispenser and Notification System Using Microcontrollers. So, studies show that a significant number of deaths and hospitalizations occur due to incorrect dosage or mismedication. In many households, caretakers or family members are required to constantly supervise patients, which is not always practical, and manual reminders are unreliable. And existing solutions are often too expensive or complex. To address this problem, we propose an entirely or IoT-based automatic medicine dispenser that ensures timely medication delivery, confirms pill intakes, and notifies the caregivers remote. Our system focuses on accuracy, affordability, and ease of use, making it suitable for the real-world deployment. Now, for the literature survey, you can see there are two tables here. Along with reviewing along with reviewing existing medicine dispenser system, we have also performed component level analysis. From the hardware perspective, the Arduino based system dominate the literature, appearing in 29 such papers due to low cost and ease of computation, but increased power consumption and cost. The Raspberry Pi are also the same. The communication systems like Wi-Fi, GSM, Bluetooth are widely used. However, GSM systems suffer from network dependency and recurring costs and reliability issues too. Sensors like IR sensors, camera, and fingerprint modules improve the monitoring, but significantly increase the system complexity and cost. From software perspectives, most systems rely on Android or web-based applications. Rest are powered by platforms like Blink, ThinkSpeak, and MQTT. While these enable remote monitoring, they introduce platform dependency, configuration overhead, and subscription constraints. Overall, existing research shows a clear trade-off between low-cost systems, limited functionality, advanced systems with high complexity and cost. This analysis motivated our approach of using lightweight controllers and with Wi-Fi and open global accessible platform Telegram for for real-time notification and achieving a balance between cost, reliability, and usability. From the following literature, we identified a clear gap, a need for low cost, a reliable uh, platform, internet-based notification system with actual intake confirmation, minimal hardware complexity, and this gap motivated our proposed system. Now, the objective and innovativeness. The primary objective of our work is to design and implement an automatic tablet dispenser that ensures medication adherence while providing the peace of mind to the caregivers. The specific objectives are first, to dispense the clear dosage at the correct time, to provide second, to provide visual reminders to the patient, third, to confirm pill intake using sensors, fourth, and the last, to send real-time notification to caregivers using IoT. Now coming to the innovativeness of a system, we use Telegram, which is a globally accessible open source platform instead of GSM or paid IoT services. The system employs two microcontrollers, Arduino Uno for physical dispensing and alerts, and ESP32 for Wi-Fi connectivity and notifications. The solution avoids heavy microcontrollers like Arduino Mega and eliminates unnecessary ICs, keeping the system cost effective and scalable. Now, going towards the methodology, the medicine dispenser consists of multiple compartments, each storing a specific dosage. A 360-degree servo motor is used, controlled by an Arduino Uno. It rotates to align correct compartment at the scheduled time. The dosage schedule is pre-programmed into the Arduino in terms of regular time intervals. At the scheduled time, the servo rotates, the pill drops in the dispensing tray, and the touch sensor activates the buzzer and the LED to alert the patient. The eye sensor is placed near the tray to detect the patient's hand movement, and once the pill is picked up, the buzzer stops, the LCD displays pill taken, and and a signal is sent through the ESP32 to the Telegram bot, which it later sends a real-time notification to the caretaker or the family members. Now, the use of two independent microcontroller ensures no processing overload, no dependency between dispensing and communication tasks, better reliability and modularity. And we have also created a similar type of 3D model using AutoCAD, which was later implemented as a working physical prototype. Now coming towards the result and discussions, the system is tested with multiple dosage schedules and compartments, and the results show that the pills were dispensed accurately at predefined times. The buzzer and LED continued until the pill was picked up. The air sensor reliably detected hand movement, and notifications were sent on Telegram in real time. One key advantage of a system is its ability to handle multiple medications with different time intervals, which is a major limitation in many existing models. To conclude, we successfully designed and tested an automotive medicine dispenser that is accurate, reliable, and cost effective. The system ensures the timely medication delivery, confirms pill intake, and keeps caregivers informed through real-time notification. This solution significantly reduces human dependency and minimizes medication errors, and is especially beneficial for elderly patients and individuals requiring long-term care. In terms of future works, we are planning to build an IoT web dashboard that can be developed for detailed monitoring. And mobile app integration can also be explored. Additional security features and authentication can also be added, and the design can be miniaturized for commercial use. Overall, our prototype demonstrates a strong potential for real-world healthcare application and scalable deployment. Thank you.
Thank you. Are there any questions?
Okay, Pushkar, please come on your first slide of your presentation, like title of your presentation.
Yes, ma'am.
So, based on this title, like it is very, uh, like if we talk about any research paper, you don't think it is very small, because the methodology part, which technique you are using, have you seen in the topic is clear, or the thing which you want to say, it is come in summarized form as based on your title?
Uh, like I said, ma'am, this is a first
Because
presentation, and we are deciding
yeah, it
upon the
is a
title.
your first presentation. Yeah, it is your first presentation. That's why I'm telling you. First, you have to cover your screen, because you are just taking a very small portion of your PPT. Another one, you have to explain your work, your technology, or the objective of your paper. It will comes in a very concise way of your title. Okay, so that might like 10 to 12 words. It will be okay and explainable. Okay, and then come on methodology part.
Yes, ma'am.
No, it is a objective methodology. So medical dispenser, automatic medicine dispenser, these all devices are already made. What exactly your work? Because it is a IoT based sensors, those are using microcontroller and Wi-Fi connectivities. Yes, of course it is there. But your contribution of your paper, you are just collecting all the data and putting in as a structure of paper. You are just doing like this.
No, ma'am, this is not a reading project. Uh, so, what uh, innovation perspective we have added
Yes.
in our
What
project?
new, what novelty in your paper? How it is differ than others?
So, ma'am, basically, we are using an online platform which you might know, Telegram, which is accessible to every person in the world. We are sending notifications, real-time notifications when the pill is taken to the caregiver or the registered person
Hmm.
after the pill is taken, and when the pill uh, falls down on the touch sensor. So we have explored such solutions, but they were based on web development, and they were based on Blink IoT solutions. And now Blink IoT has a subscription based system, which is not really feasible for multiple people, as it is also complex for using, and it is not accessible for them. So we decided to explore a more accessible option, which is Telegram. We first make a chat bot, and then we send the notification real-time notifications after the pill drops down.
Okay, so you want to say that ki they are giving a alert message to the patient for taking a medicine and something like this.
Yes, ma'am. Also to the caregivers who are
Hmm.
notified when the pill falls down on the touch sensor.
Okay.
That so
But
basically
I
the Arduino controls.
yeah. Yes,
Uh,
please, please.
yes, ma'am. Please continue. So the Arduino controls the timing of the pills. After a particular time period, the servo motor rotates and the pill falls down on the touch sensor. We get a notification, or a notification sent on the caretaker's cell phone,
Hmm.
and we get to know if the pill has been taken by the patient or not.
Okay, Pushkar, your work is very good, but you have to elaborate more because it is fruitful for society and senior citizens. Of course, those are forget to take a medicine. It is yes one of the good work, but you have to elaborate more the work which you are doing. It is a very vast subject, so you have to work more on this era. Okay,
Yes, ma'am.
okay, fine. Next, please, ma'am.
Yes, ma'am. Thank you, ma'am. Thank you, Pushkar. Moving forward, I would like to request Sir Chakraborty to kindly present his paper titled Cognitive Cloud Manufacturing, a Theoretical Foundation for Twin-Based Scheduling and PCF Optimization. Do we have you here with us, sir?
Yes, am I audible?
Yes, sir, you're audible.
Good afternoon, everyone. I am presenting our work titled Cognitive Cloud Manufacturing, a Theoretical Foundation for Twin-Based Scheduling and PCF Optimization. This work is authored by myself, Mriganko Chakraborty, Tamasha Chakraborty, Prosun Ghoshal, and Tarun Kanti Jana. Our focus is to build a formal, analytical, and sustainable scheduling framework for cloud manufacturing. Modern manufacturing heavily relies on cloud-based coordination. However, current systems lack a theoretical foundation to analyze time, energy, and carbon trade-offs. Digital twins are used inconsistently, uncertainty is not formally handled, and no closed-form sustainability models exist. Because of this, scheduling decision cannot be verified, predicted, and compared analytically. The objective of this work is to create a formal cognitive cloud manufacturing framework using mathematical digital twins and a priority based cognitive scheduler. The challenges include modeling heterogeneous machine uniformly, capturing uncertainty and rework, balancing speed versus energy versus carbon, and ensuring workflow consistency. Cloud manufacturing shifts production from local factories to a virtual service based environment. Resources are discovered, scheduled, and used on demand. It improves scalability, resource utilization, and global collaboration. The ecosystem consists of providers, consumers, and cloud operators. The existing cloud manufacturing research lacks a formal digital twin theory, closed form equation for time, energy, and product carbon footprint and analytical multi-objective evaluation. Our work directly fills this gap by introducing a fully mathematical cognitive framework. Our framework consists of standardized digital twins, belief-based uncertainty modeling, workflow feasibility checking, multi-objective optimization, and the novel CTAEFT cognitive scheduler. This entire system is analytical and dataset free. Digital twin semantics. Each machine is modeled as a formal digital twin with states, controls, time, energy, and carbon functions. Each operation is presented as a typed service with input-output rules, processing mode such as fast or green, and compatibility constraints. This ensures uniform modeling across heterogeneous machines. Each twin is assigned a belief distribution over processing time, energy, quality, and rework probability. These beliefs are updated using real world observation and expected values guide scheduling decisions. Workflow feasibility ensures correct task service machine, constant satisfaction, and mathematically valid rework. The scheduling objective is J equals to alpha dot C max plus beta into E of W plus gamma dot PCF. Here, alpha controls time, beta controls the energy, and gamma controls the carbon priority. This allows transparent trade-off controls. Now, the CTAFET scheduler assigns tasks based on a weighted scoring rule using expected finishing time, energy, carbon, and value of information. The steps are find ready task, compute scores, select best task machine, update beliefs, repeat until the completion. This procedure predictable and in interpredictable schedules. We evaluate the framework using the symbolic caselets instead of simulation. The single site flow line, rework loop with uncertainty, and shared supplier with parallel machines. All results are obtained analytically using equations. Now, Caslet A, the flow line. In this series, a serial workflow, makespan is a sum of task times, energy, and carbon also add up. When alpha is high, it implies fast modes are selected. When beta and gamma is high, then green modes are selected. This clearly shows priority-driven behavior. Next, the cascade rework loop. Here, failed products return for rework with probability PR. The expected amplification factor is phi equals to 1 by 1 minus PR. That is, time, energy, and PCF product carbon footprint are multiplied by this factor. This proves the quality improvement is mathematically critical. Now the scenario, 10 scenarios were generated by varying alpha, beta and gamma. Each scenario produces symbolic estimates of mix span, energy and carbon footprint. Extreme settings give faster or greenest schedules while middle values give balanced trade-offs. Now the time energy trade-off, this scatter plot shows a clear trade-off frontier. Increasing alpha shift the solution left, that implies faster, and increasing beta or gamma shift it downward, that implies greener. So no point is optimal in all three objectives, proving the importance of multi-objective scheduling. So finally, we can conclude, we propose that a lightweight but rigorous theoretical foundation for cognitive cloud manufacturing introduced formal digital twin semantics, developed closed-form models for time, energy, and carbon, proposed the CTAEFT cognitive scheduler, demonstrated that the rework act as a geometric cost amplifier, and showed that all scheduling decisions are auditable and interpretable. This makes the framework suitable for sustainable and intelligent manufacturing planning. So these are the references that we have used. Thank you for your time and attention. I will be happy to answer any questions.
Thank you, sir. Are there any questions?
Okay, Mrigang.
Ma'am, it's Mriganko Chakraborty.
Okay, fine. So you are talking about digital twin.
Yes.
Can you explain and how it is used in your research work?
Actually, each digital twin is modeled as a tuple, where you can see there is explained that x, u, f, c, q, and e and psi as a function, where x is a system state, u is a control input, f is a state transition function, c is a cost time model, q is the quality yield model, and e is the energy carbon model with operational constraints. Here we use the digital twins. Digital twins model each physical machine as a formal cyber physical entity with state, control, symbolic time, energy, and carbon functions. They serve as a mathematical foundation for scheduling and sustainability analysis.
So have you shown this work in your PPT? I don't think
Uh,
so. You are, what you are explaining, it is not in your PPT.
Ma'am, it is on the paper.
Yeah, it is
As
on the
there is a
paper.
time constraint in the PPT, so we have shown entire thing in our paper only.
Okay, come on fifth number of slide of your presentation. So, cognitive cloud manufacturing framework.
Yes.
So, you are creating a cloud based on your work. Are you saying like you are proposing to make a cloud manufacturing, cloud making? Is it
We are
so?
manufacturing with the cloud.
Yeah, manufacturing
With the cloud or using the cloud.
cloud.
Yes.
Okay. So that particular cloud will be work like AWS and Google, similar like this.
Yes, yes.
Okay. So how they are different than all those companies are working in these days also and very great work. So do you think it will be compete of these industries?
Actually, this is not existing for old machine wear.
Back pardon?
This is not existing for old machines. We are trying to implement.
You are trying to implement. Okay. So have you give the cloud space to the company those are connected with you and how much amount and the specific criteria? Are you
Uh,
decide something?
yes, that is the motive, but she is not yet done.
Not yet done. Okay, fine. Thank you.
Thank you, ma'am.
Thank you, ma'am. Thank you, sir. Moving forward, I would like to request Sir Jutang Swear to kindly present his paper titled Comparative Analysis of UNet-Based Architectures for Grasshopper Segmentation in Agricultural Images. Do we have you here with us, sir?
Yes, ma'am. Can you hear me?
Yes, sir, I can hear
Yeah,
you.
yes. Is my slide visible, ma'am?
Yes, your screen is visible. Can you please put it in slideshow mode?
Okay.
Yes, it's visible.
Okay.
You may start.
Okay. Good afternoon, everyone, and especially to our special ma'am who's on here to for us to reflect
Sorry
on.
to disturb you,
Yeah. Yes.
ma'am. Have you give Priyanshi ma'am? Have you
Yes.
do you give some format of presentation or any sort of presentation they are using?
Ma'am, I think
Any
usually,
formatted presentation?
no, ma'am, usually presentations are allowed as much as I know.
Okay, okay, fine, fine.
Yes.
May I proceed, ma'am?
Yes, yes, sir.
Okay. Thank you. The topic of my paper is comparative analysis of unit-based architectures for grasshopper segmentation in agricultural images. My name is Jutang Holaswer, and I'm doing under the guidance of Sir Datta Kandar and Gautam Sahasar from Northeastern Hill University, Shillong, Meghalaya, India. And why the motivation is why grasshopper segmentation. In real paddy field images, grasshoppers are hard to detect. So camouflage, why? Because they are hard to detect because of the camouflaging nature of the grasshopper and also because of the cluttered vegetation backgrounds. There might also be illumination changes like shadows or glares and occlusions, which means that it means like there are a little bit disturbance in the images, grasshopper images in the paddy fields. So manual scouting is slow and error prone at field scale. So detect these grasshoppers manually, it is a very slow process and it's also a very error prone process. So to help this, we use with the help of deep learning like pixel-wise masking. It can support, this is one way of detecting grasshopper. Pixel-wise mask can support precise monitoring. And also we can get the targeted control. We can control the number of grasshoppers which are, or it can give us a prediction of how much grasshopper it has accumulated. The goal here is to improve segmentation accuracy under natural field conditions while keeping models practical for deployment. So here in this paper, it contributes, we have compared three unit-based segmentation models on a custom field dataset. Datasets here have been collected, have been created custom. It has been made from scratch, and we have not used any ready-made datasets. And we have used three models. Number one, the baseline, the unit model, which is a traditional unit because it is shaped like a U. That's why it's called a unit. And another one is we have compared with a unit with the help of a pre-trained encoder called the VGG16. It's a transfer learning. And another method which I've used here, I've implemented is a unit with ResNet 50 encoder. And in the decoder blocks, I have incorporated squeeze and excitation, also known as the SE blocks. The details of this will be discussed after some time. Evaluation, for the evaluation process, we have used dice coefficient and IOU, which is the intersection over union. This is the mass overlap. We have also done a parameter count, which will help us determine the model size and the deployment costs, and qualitative mass comparison also on real field images. Now, datasets here have been collected are 4,743 images, and they have been manually annotated with the help of Label Studio. All these images have been labeled manually. And for the training purpose, we have split them into 80% for the training set and 20% for the testing data sets. Augmentation also has been applied, like flip, rotation, brightness, and angle rotations and all. Why this dataset is challenging? Dataset is challenging because we have collected from real field images, which it is challenging because of natural illumination variation and background complexity, grasshopper posture variation, plus partial occlusions. Strong camouflage makes boundaries ambiguous. That's why the dataset is very challenging. So here I've shared some the models share the unit encoder decoder structure with skip connections. Here I've chosen the unit as the baseline because unit is the most baseline models for most of the segmentation in images. So segmentation in for a layman means we remove the boundaries and we leave only the detected object. So in that way, if we remove the background, if we remove the background of the object, only the targeted object will be placed in the image after the processing, and hence we can detect where in the image is the required detected object. So variance here we have used baseline units, which consists only of simple convolution encoder, VGG16 encoder, which is deeper, and pre-train, it is pre-trained in ImageNet and ResNet 50 encoder and squeeze and excitation. This is a residual features plus channel attention. SE blocks here, which is the squeeze and excitation blocks, it acts like a channel spotlight to emphasize informative features. That means it is extracting the important features from the images. Pre-train is also helping us in feature extraction, but with the help of adding more of the SE block, it is like a channel-wise attention. It helps us to emphasize more on important features and leave the unimportant features aside. So these are these are the three architectural diagrams here in the traditional unit baseline. We have the encoder, decoder. It is purely a convolutional network. But here in the unit with VGG16 encoder, I have included the VGG16 as the encoder. And here I have used the ResNet50 as the encoder. And in the decoder part, I have used have included SE blocks in the decoder part. This is the first time which we have done, and it's also first time used for Grasshopper. And the training details here, I have used TensorFlow 2.2, version 2.2, pre-trained encoders loaded for VGG16 ResNet50. For optimizing, I've used the Adam optimizer. Learning rate is 1 e to the power minus 4, which is 0.0001. Dice loss to handle class imbalance. I have used dice loss here. And I have run the implementation for 50 epochs, which a batch size of 8. And early stopping is also done based on validation dice. If it cannot improve more than the setting standards, it will stop. Early stopping will occur. And these are the metrics which I've used. Intersection over union. This is the formula. P stands for the predicted mass, and G stands for the ground truth. Means the original one, means we have to compare here. And this is for the dice loss. Parameter count also has been taken into account for memory and to compute the cost. And why dice loss is used? Because Grasshopper pixels are a small fraction of the image. Dice loss directly optimizes overlap and helps with class imbalance. So this is the graph which I have achieved from the results. Baseline unit. Baseline, the dice here I have achieved is 0.89, and the number of parameters included in this model is 31 million. The ResNet 50 plus SE, the accuracy is 0.91, or you can say 91.12%, but the parameters has increased to 43.9 million. The best trade-off here we can see is the unit plus VGG16, because here we have a dice accuracy of 91.52 or 91.52%, IOU of 85.58%, and the parameter counts is also only 19.6 million. And here is the parameter count bar graph. And these are some of the images which I've got. This is the original image, and after segmentation, removing the background, this is the unit output. You can see there the grains are not fine, the boundaries are not fine here, they are very rough. And here with the help of VGG16,
This
it
is a
is
gentle 9 minutes reminder.
okay. Thank you, madam. And here in VGG16 output, it is little bit improving compared to the unit output. But out here, you can see with the help of the channel-wise attention base, we have used ResNet50 and squeeze and excitation for channel-based attention. Here it has given a very fine and a very refined boundary, and as compared to the original image. Observations here: baseline, unit, coarse and incomplete mass regions. What is the output from the VGG16? It is much cleaner, compact mass in this diagram, but with sharper boundaries. What is the output of this one? Detailed mass attention helps suppress background noise. So the key takeaways here is pre-trained encoders improve feature extraction in plotted scene. SE helps emphasize informative channels, but complexity matters. ResNet 50 plus SE increases parameters substantially. For practical deployment, that means for real-time employment, so for edge devices or mobile devices, VGG16 offers the best balance because it has the highest dice loss and IOU, and with 19.6 million parameters it takes only. So for recommendation, we start with unit with GC16 and add attention if you can afford extra computation. Conclusion, all three variants can segment grasshoppers in real field images. UNET plus VG16 gives the best trade-off. ResNet plus 50 performs stronger but increases computational costs. For future work, we expand the dataset diversity and evaluate multiple pest species, measure inference latency and test deployment, and explore lightweight models for stronger attention like spatial transformer based for video and video processing. And these are the references. Thank you. Thank you, Madam.
Thank you, sir. Are there any questions?
As you shown in your paper, you are using ResNet and VGG. Have
Yes,
you
madam.
done this practical on your machine for
Yes,
image
madam.
processing? Okay,
Yes,
which
madam.
platform you are using?
I'm implementing in Python, madam, in the TensorFlow.
TensorFlow.
This
Okay.
one, madam, I've
So,
mentioned here, training details.
okay. So, for Python, you are using Jupyter or any other platform?
I'm using the online one called the Lightning AI, madam, which is online
Online.
cloud-based. Yes, ma'am.
Okay. So online, all the libraries and functions are inbuilt already. So how you differentiate that? Which sort of functions you are using for VGG and ResNet? Because all are available. But if you use some offline platform, so that you have to focusing on various libraries and various functions.
Yes, madam.
So I suppose you have to use offline rather than online method.
Madam, online is everything we can import, madam. All everything
Yeah,
we can import, madam. So everything it has been provided from the platform. We just import the pre-trained networks and
that's why you are using.
yes,
But
madam.
as I suggest, because online is for a limited time only or for correction work, not it is a platform for doing a such type of research. Because research is basically we are doing research for a future perspective, not for short time, na?
No, madam, actually, I'm using
Uh,
a paid version, so it is giving me full, it's
uh,
very equivalent to the offline, madam. I'm getting all the full version of the.
Yes, you have to install all these libraries and uh, like execution of your work is based on your Anaconda or some other platform, so that it will be fruitful for society also, and your work is good. But if it is really work, then definitely it will fruitful for society and easy to diagnose the images.
Yes, madam.
Fine. Okay. Now, you are talking about come on, last reference part.
Francis, ma'am.
Ah, yes. So here I'm seeing you also taking only four references, and the paper are which you are take as a reference is like 2018,
Oh, these
2000.
are, oh, madam,
Yeah,
these
this is
are
the
only
previous one, na?
the previous. Actually, these are not the models which I'm following. These are just the pre-trained networks, madam. I'm referring to. This one is not the actually. This is the paper on, like this number three is a paper on ResNet 50. Number two is a paper on VG616. Number one is a paper on unit, a traditional unit, and number four is a paper on squeeze and excitation networks. But
Okay, it
the
is okay, but the work of deep learning is moving on.
yeah, yeah, I understand,
If
madam.
you take a latest paper and you are working on VGG and ResNet, so many work had done in these days.
In the
So it will
paper,
be better for you.
hmm. In the paper, madam, I've included latest works also, but here I've
Yeah.
included only the things which I've used in the slides, madam, for this slide here. I've used VG, that's why I've put here two, three, four, just for the current slide, madam. But in the paper, I've included all those previous works also.
But I'll just suggest you use because encoder 4 is available for VGG 16 and you are using 2.
No,
So if
madam. I'm sorry, madam, that I have to. This is for referencing, madam. This is not encoded.
yes, this is for reference only.
Yes,
Okay, fine, but you can use a latest one so that the work will more effective.
yes, madam. Thank you for your kind.
Thank you. Next, please, ma'am.
Thank you, madam.
Thank you, ma'am. Thank you, sir.
Thank you, madam.
Moving forward, I would like to request Ma'am Siddhi Kalyani to kindly present her paper titled E-commerce versus Traditional Retail, a comparative analysis of consumer preferences. Do we have you here with us, ma'am? Is anybody else from the team present?
Hello, ma'am. Hello.
Yes, ma'am. Yes, you are audible. Uh,
Hello.
you can
Ma'am,
share
my
your
name is Gulrukh Nazneen.
Sorry.
My name is Gulrukh Nazneen.
Yes.
Ma'am, my paper title is Recent Advances in Deep
Ma'am,
Learning.
your turn is like after this there's one paper and then it's your turn.
Okay, 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 ma'am. Sorry for the disturbance.
No worries. Siddhi ma'am, were you sharing your paper? Is anyone there? Siddhi, can you reply?
Ma'am,
You
please
are.
move forward. Next paper you can take, and after that you can connect with Siddhi.
Yeah, ma'am. Ma'am, can
Um,
I present? I'm next, I think.
just a second. Yes, ma'am. I would like to request Ria Deria to kindly present a paper titled Explainable AI in DNA Decision Trees, Enhancing Interpretability in Genomic Sequence Analysis. You can share your screen, Ria.
Yes, ma'am.
I also request all the remaining participants to kindly take care of their network and their presentation so that we can conclude the session on time.
Ma'am, am I audible?
Yes, you're audible and your screen is also visible.
Okay.
You may start.
Yes. Uh, so good afternoon, ma'am. My name is Ria Deria. I'm from NMIMS University, Mumbai, and I'll be presenting my research work titled Explainable AI in DNA Decision Trees, Enhancing Interpretability in Genomic Sequence Analysis. So, to begin with, DNA sequence analysis plays a crucial role in understanding the genetic mutations that may be linked to various diseases. As machine learning also is increasing and it's highly important in genomics, one major challenge that we face is that many high performing models they act as black boxes. Now, what is the term black box? So black box means something wherein you can't understand what is behind the actual result. So it gives you accurate predictions, but they don't explain why, as in how you have arrived at those predictions. So in a field like healthcare where decisions directly impact diagnosis and treatment, this lack of transparency becomes a serious limitation. And clinicians need models that not only perform well, but they also need to know the reasons, which provide clear reasons and clear explanation as to how we have reached to the conclusion. So this is where explainable AI or XAI techniques they become extremely valuable and useful. So our work it aims to address this challenge by combining an interpretable model, decision trees with model XAI techniques like SHAP and LIME. So, moving on to the problem statement. Firstly, there are many high performance models which are not transparent, so which makes it hard for clinicians to trust or understand the predictions, as I mentioned before. So, we need models that balance accuracy with clear explanations. Second, we move on to the advanced models like neural networks or deep learning models and Ansible models, which create opaque decision paths. So it's very difficult to understand what is going behind those results. And the non-linear transformations are also difficult to trace, making validation challenging in healthcare. Thirdly, the genomic data has complex feature interactions. Black box models can capture these patterns, but they cannot explain the reason behind why. So these challenges show why our explainability models like SHAP and LIME are essential and why our research focuses on making genomic predictions more interpretable. Moving on to the objectives. So, our main objective is to build an interpretable ML framework for DNA mutation classification. We've used a decision tree as a transparent baseline model, and we've integrated with SHAP, which is global and local explanations, and LIME to explain the predictions at both global as well as the local levels. So, we evaluated the performance using the metrics like accuracy, precision, F1 score, and recall. And lastly, we've shown how interpretability improves trust and understanding in genomic predictions. So now let's have a look at the approach that we've followed, which is mainly focusing on transparency with accuracy. I'll tell you all the accuracy at the end of the by the end of this presentation. So, firstly, we've made use of the decision tree classifier, which is inherently interpretable glass box model, and it gives a clear foundation for understanding the predictions. We enhanced this using the post hoc XAI methods as a SHAP and LIME for deeper and for actionable insights. Which lastly we found out that the achieved accuracy was almost around 80%. So the framework achieved around 80% accuracy, successfully balancing predictive performance with the level of interpretability that we wanted for any clinical use or trials. Now, let's have a look at the literature review. So, I read almost 10 to 11 papers, and our review showed that while many models perform well, but most fail to combine both accuracy and interpretability. There were models and there were papers in which the accuracy was very good, but they were lacking in terms of in terms of interpretability. So, we have tried to build to fill up that gap. Rule based models are interpretable but less accurate, while black box models are accurate but they lack interpretability and transparency. Hybrid XAI approaches like SHAP and LIME, they improve this and they bridge the gap between the two. But few studies integrate them with inherently interpretable models like decision trees. This is the main gap what our research aims to address. So now let me emphasize more on the research gap. Firstly, most black box models they lack clinical interpretability, making it difficult for practitioners to trust the process or to even trust the predictions. Second, the rule-based systems they are clear, but they are too simple to capture the complex interactions in genomic data, especially. Third, although SHAP and LIME have strong potential, but their use in genomic variant classification remains very limited. And finally, while decision trees are interpretable, they often sacrifice accuracy because they are not very advanced models or not very high level models. So, in my research paper, we have implemented decision trees, random forest, along with logistic regression. I'll move on. I'll explain that part later. And we have seen and we've compared how the accuracy has improved when we use better models like random forest. So now let's have a look at the tech stack. We've used the scikit-learn library that is available in machine learning, models like decision trees, random forest, and logistic regression. We've done the backend in Python. For explainability, we integrated SHAP to analyze the global and local feature contributions and Lime to explain the individual predictions using local models. So data processing was handled again with the help of Pandas and NumPy library. And for visualization, we made use of Matplotlib and Seaborn libraries that are available in Python. So everything was done on Jupyter Notebook, and we've mainly done the backend on Python. So now let's have a look at the methodology and the data models that we've made use of. Our methodology begins with data pre-processing, which is the first and the initial step. So before that, let me tell you all about the data collection part. We have used real-time data, not real-time data, but it was the real data wherein we picked up the data from a hospital, but we've just manipulated the values here and there due to privacy reasons. But this is a real customer data that we got from the hospital, which has shown the real gene predictions of a particular customer. So our methodology begins with data preprocessing, wherein we've cleaned the data set, we remove the unnecessary identifiers, we even handle the missing values, and we've encoded the categorical features for standardization and normalization purpose. Next, for model training, we first split up the data into training and testing. The split was 80% to 20%, and we've tested decision tree, random forest, and logistic regression respectively for binary outcome prediction. Finally, we integrated the explainability techniques like SHAP and LINE for global feature insights and for local insights as well. So now let's have a look at the results and analysis part. So
This
firstly,
is a
when we
9 minutes reminder.
yes, ma'am. So, firstly, when we applied decision tree classifier, we achieved a overall accuracy of 78.5%. And here is a report that we've achieved. In summary, the model provides a solid baseline, but it needs improvements in terms of balancing between the 0 and 1 categories. Nextly, the random forest and SHAP analysis, we used a random forest classifier with 100 trees to improve the robustness and capture nonlinear feature interactions. And we've made use of SHAP also to highlight the. So SHAP analysis showed that here is a plot that I've displayed. We can see that position, chromosome, and gene. These are the top three variables that have highest impact on our model. So this was the main purpose of SHAP, that we've understood how each model is typically getting affected by the target variable. Lastly is the logistic regression and LIME analysis. Our logistic regression model combined with LIME, it achieved 81% accuracy. This was the highest accuracy out of the three models. And here is a classification report of it too. So now let's have a look at the comparative insights and challenges. So decision tree, it's easy to understand but biased towards the majority class. Random forest with SHAP, it added robustness, but it captures features, interactions, and it provided a global interpretability. Lastly, logistic regression combined gave us the best accuracy. It also provided localized explanations, but again, the poor disease detection happened because of class imbalance. So XAI methods, SHAP and LIME significantly improved the transparency. Gene, chromosome, and position consistently emerged as key predictors. This we found out using the XAI models. So now let me conclude my presentation. We developed an interpretable framework combining decision trees with SHAP and LINE, and we achieved an overall accuracy of 81%. These XAI methods, they enhanced our trust and also provided local explanations and improved the model audibility overall. Um, our approach balances predictive performance with interpretability. Lastly, for future scope, firstly, biologically inspired models can be developed to align predictions. Second, knowledge graph integration could also be an added way of interpreting things better in a better way, and real-time clinical applications. So these are the references. I've just listed the top four, but there are seven more because I've made use of 11 to 13 references. And these are from the latest papers from 2021 to 2025. Thank you.
Thank you, Ria. Are there
Thank
any
you, ma'am.
questions?
Okay, Ria, as you work on Jupyter and Matplot and NumPy and all the libraries you are using,
Yes,
your
ma'am.
presentation is good, but the things which you are using in slide number 13 and previous one, the images you are using is not correlated with your content.
Okay, ma'am.
So, what is the use of these images which you are using? Yes.
So, ma'am, these. So, firstly, I'll talk about the 10th slide. Here, I've plotted the SHAP summary plot. So, these
No,
images
it is
just
okay
maybe.
with graph, but the image which you are using in left hand
Yes,
side, na,
yes, ma'am.
the-
This you need to see this
these are
image.
the professional mm, work, na. Why you are using these type of images?
Okay, ma'am. Ma'am, as
Hmm.
no, they are not provide us any template, so I made use
They
of.
are not providing template. It is
Correct,
okay with, but pre presentation means the things should be summarized, okay,
correct, ma'am.
with a beautiful manner. But
Okay,
for your future perspective, telling you.
okay, ma'am.
Okay, now,
Ma'am, I think I'll replace the template.
yeah, you have to. Like
Oh.
random forest, can you please explain this term, random forest, what exactly it is?
Yes, ma'am. So, ma'am, random forest is when it's a combination of multiple decision trees, and when we combine multiple decision trees, it's called random forest. So, a tree is a single tree, and why is it called a forest? Because you're combining multiple decision trees. So, it helps in training the model in a better way, and in like
Hmm.
and then we can achieve a better accuracy using a random forest model since it's an ensemble model as well. That's why. So it is just used for better accuracy and interpretability since you're combining more models for interpretation.
Okay. And if you compare with gradient boost or algo or
Yes, ma'am.
to
Ma'am, we
is
made use of gradient boosting algorithms as well. I tried LSTM models also, but
hmm,
we didn't achieve a better accuracy because of the class imbalance. So, logistic regression and random forest were the two models that were giving us the best accuracy. We even tried other models, but we didn't get better results over there.
okay, fine. Okay, ma'am. Thank you.
Thank you,
Next,
ma'am.
please. Okay.
Thank you, ma'am. Next, Siddhi, are you there now?
Yes, ma'am.
All right, you can present next.
Yes, ma'am.
Yes, your screen is visible. You may start.
Okay, ma'am. Good afternoon, everyone. I will be presenting my topic title E-commerce versus traditional retail, a comparative analysis of consumer preferences. Retailing has undergone significant changes with the rise of digital platform. At the same time, traditional brick and mortar stores continue to play an important role. This presentation explores how consumer preferences are shifting and how both formats coexist. Research overview, mixed method design, primary data from questionnaires, secondary from literature and industry reports. Key factors, investigating convenience, trust, risks, and customer experience. Demographic insights, analyzing preferences based on income and age. This study follows a mixed methods research approach. Primary data was collected through questionnaire to understand consumer opinions directly. Secondary data was gathered from research papers, articles, and industry reports. This study focused on factors such as convenience, trust, pursuit, risks, and customer experience. Demographic variable like age and income were also considered. The evolving retail landscape. The rapid the retail industry has changed rapidly due to technological advancement, increased internet penetri- penetrations, and smartphone uses have boosted online shopping. Consumers now prefer quick, easy, and time-solving purchasing option. E-commerce platform offer wide product variety and competitive pricing. As a result, consumer buying behavior has significantly evolved. The enduring appeal of physical stores. Despite the growth of e-commerce, physical retail stores remain relevant. Many consumers prefer seeing, touching, and trying product before purchasing. Immediate ownership of goods is another major advantage of offline storage. Personal interaction with sales staff builds trust and satisfaction. Today, Today many businesses are adopting omni-channel strategy to combine both formats. Drivers of consumer behaviors, trust and risks. Critical drivers in online purchase decisions, social proof, online reviews, and peer influences significantly impact purchases. Customer experience, store trust plays a very important role in online purchasing decisions. Consumers often worry about payment securities, product quality, and delivery reliability. Social proof such as review, rating, and recommendation strongly influences buying behavior. In traditional retail, face-to-face interaction builds confidence. In store experience continue to be a key driver of customer loyalty. Research objective. Key factors study factors affecting buying behavior in e-commerce and offline retail. The objectives include studying factors affecting buying behavior. Trust and risks. Identify the extent of trust and perceived risks in online and offline shopping. Understanding trust and perceived risks. Social proof. Study the influence of social proof on e-commerce consumer behavior. Analyzing social proof in e-commerce. Customer experience. Determine the influence of customer experience on offline retail choice. Examining customer experience in offline retail. E-commerce barrier. Determine challenges to e-commerce adopting and emerging economies. Research methodology and data. Comparative design, descriptive research, design both quantitative and qualitative. The research followed descriptive and comparative research design. Primary data structure questionnaire from 50 diverse response using satisfied random sampling. Primary data was collected from 50 respond using structured questionnaire. Secondary data, academic journals, industry reports, and online database. Secondary data was obtained from academic journals and industry response. Both consumer preferences, e-commerce versus traditional retail. Trust barriers. Uh, The findings show that consumers prefer e-commerce for convenience and time saving. Online platforms also allow easy price comparison and access to a wide variety of products. On the other hand, traditional retail is preferred for trust and personal service. Immediate product availability is another advantage of offline shopping. Thus, both formats offer distinct benefits to consumers. Trust barriers and social proof in e-commerce. Trust barriers, payment security concern 30%, product authenticity doubts 25%, negative delivery experience 20%. Social proof and influence, positive review influence 35%, negative review data 30%, rating influence 20%. Major trust barriers in e-commerce include payment security concern and product authenticity issues. Delivery delays and return problems also affect consumer confidence. Positive customer review and rating encourage purchase decision. Negative review can strongly discourage potential buyers. Therefore, secure payment system and transparent return policy are essential. Key differentiators and future outlook. Traditional retail differentiators, personalized service 30%, in-store experience 25%, knowledgeable staff 20%, e-commerce barriers in developing region, infrastructure limitation 35%, lack of digital literacy 30%, data privacy concern 20%. Traditional retail stand out due to personalized service and human interaction. E-commerce face challenges such as digital literacy, infrastructure gap and data privacy issues. However, e-commerce continued to grow due to convenience and accessibility. The futures of retail lies in integrating technology with personal services. A balanced omni-channel approach will define the next phase of retailing. Thank you.
Siddhi, presentation was very good, but what exactly work you are doing in your research paper, I'm not getting. You are just explaining the traditional marketing method and e-commerce method, but what exactly the work you are doing? You are just explaining the things. No novelty I'll seen in your paper. Have you explained this?
Ma'am,
What
actually,
sort of
your
your
voice is
work?
breaking. Ma'am, actually, your voice is breaking. Can you repeat the question?
I'm asking, Siddhi,
Yes, ma'am.
hello. What sort of
Hello.
work you are doing in your paper? Hello.
Yes,
Am I
ma'am.
audible? Am I audible?
Yes, ma'am, you're
Yes,
audible.
yes.
Okay, fine. What work you are doing? You are just explaining the traditional method, e-commerce, the use of e-commerce, comparison is also there. But what you are doing in your paper, what sort of novelty is there?
Yes, ma'am. Actually, I have taken the responses from the individuals which are surrounded by me. I have taken their responses, and according to their responses, the result is actually they are convenient with the e-commerce.
So you have to add all these responses, na?
Yes, ma'am. Actually, in the research paper, I have mentioned all these things. In the
You
presentation,
have to
I
add
didn't
these
mention.
responses or compare. You are not adding all these. You are just defining what exactly the meaning of e-commerce, what is the
Yes,
traditional
ma'am.
method. But research work which you are doing at your part, you are not adding them. Any calculation,
Yes, ma'am. Actually, in the
any
presentation, I didn't mention that, but this paper is only on the primary data which I have collected.
You have to show the data so that
Yes,
we can
ma'am.
think like the work is available and you are doing something. Okay,
Yes,
fine.
ma'am. Yes, ma'am. Thank you, ma'am.
Yes, next please, ma'am.
Yes, ma'am. Thank you, Siddhi. Moving forward, I would like to request Ma'am Gulrukh Nazneen to kindly present a paper titled Recent Advances in Deep Learning for Low Dose Medical Image Enhancement. Do we have you here with us, ma'am?
Yes, ma'am.
All
Good
right.
afternoon, ma'am.
Good afternoon, ma'am. You can share your screen now.
Yeah, yes, ma'am. Just give me a minute. Is my screen visible, ma'am?
Yes, ma'am, your screen is visible. You may start.
Yes, ma'am. Good afternoon, everyone. My name is Gulrukh Nazneen. I'm here to give presentation or just to explain the brief about my research on recent advances in deep learning for low dose medical image enhancement. My co-author is Dr. Khushbu Khurana, ma'am. I am a PhD scholar. Dr. Khushbu Khurana, ma'am, is my guide. Under her guidance, I am doing my research work. Medical imaging plays a crucial role in diagnostic treatment planning and monitoring of diseases. PET and MRI systems can provide analytical and functional neurological disorder detection. This leads to radiation exposure risk, and economic cost of radiopharmaceuticals may pose significant burden on patients. There is a need to mitigate image quality degradation during low dose PET image and transform it to synthesize high quality PET images. In past few years, deep learning based image enhancement methods for low dose medical imaging have drawn a lot of interest because of their promise to enhance image quality by lowering patient radiation exposure. In order to understand the integrate mapping between low dose, noisy images and their high quality counterparts, these methods make use of artificial neural networks. For patients receiving CT, X ray, and PET scans, low dose medical imaging is essential to minimize radiation exposure. Nevertheless, dias- sorry, lowering the dosage frequently results in more noise and a loss of fine details. In order to improve the quality of low dose medical photographs while maintaining clinically relevant features, this study suggests a deep learning based method. Medical imaging is essential for illness monitoring, diagnosis, and treatment planning. However, radiation exposure via imaging methods such as CT can be hazardous, particularly for sensitive groups like pregnant women and children, or in situations that call for frequent imaging. Although low dose imaging lowers this risk, image quality is sometimes sacrificed, resulting in less contrast and more noise. There's another imaging technique, that is super resolution technique, which aims to clarify the images by cleaning the sharp edges or details of images may be enhanced. With super resolution techniques, there will be improved diagnostic accuracy, reduced radiation, while maintaining quality, clarity, and in complex anatomies, etc., like structures and all. Let's move to the literature survey. Here is some literature survey. I have referred around 34 papers, out of which some interest, limitations gain my interest for research area. As deep learning gained attraction in medical imaging in 2010, in the initial research focused on denoising and super resolution issues, one of the first study to perform this kind of thing used a deep convolutional neural network to denoise low dose CT images. Results demonstrated that CNNs may effectively lower noise levels without sacrificing structural features or diagnostic information. This research introduces a deep learning based method aimed at improving the quality of low dose medical images. The proposed approach utilizes a specialized CNN architecture designed to reduce noise, enhance fine details, and maintain diagnostic integrity. Here is some study related to the deep learning methods. Like a study implemented Hitzmann's method and statistical test and compared ultra high resolution CT with conventional resolution CT across varying fields of view, showing that ultra high resolution significantly improved image quality at reduced field of views, whereas high resolution CT showed a no benefit below 160 mm. However, the high radiation dose associated with ultra high remains a major limitation. That the limitation of ultra high is that it does not work, or it is not ideal for small fine structural assessments. Another study that gained my interest is the K-Capitu fractional differential operator. It was developed to improve picture contrast and detail, especially in environments where varying lighting. Their approach increased visual quality by showing remarkable versatility across a variety of lighting settings. But there were limits to the method, such as the over enhancement risk and less efficacy in homogeneous sections of the image. So there's some room or some scope for improvement. From this literature, these are the some key points that are left for the research point of view, like in image enhancement and super resolution. Images in low light conditions often suffer from various common corruptions such as noise and high quality and over enhancement risk. Another one is inadequate improvement for sub regions. Now, these are some more literature reviews. that gained my interest. Another, like someone utilized a survey utilized cycle GAN to enhance low dose city images specifically for radiation therapy applications, and it faced challenges in accurately reconstructing low contrast regions and fine bone structures, which may limit its precision in analytical, complex, and diagnostically critical areas. Another study also states that a 3D neural network combined with a spatial brain transform to enhance low dose PT MRI pictures, resulting in superior image quality while effectively maintaining integrate brain structures. Out of this literature review, these are some key points that can be moved forward for research, like to enhance the model's generalizability across various types of medical images. Regions with a low CNR are particularly challenging for noise reduction algorithms, and incorporating multi-model imaging data or applying the model to larger, more diverse data sets. These are some public data sets that can be used, that can be implemented for this research. Now, I have found out this research gap. Like while deep learning techniques have been successfully applied to image enhancement and super resolution, there is a lack of research addressing the context of low dose medical imaging. Images in low light conditions often suffer from various common corruptions such as noise and high contrast. By generating this cohesive model, the study will give a cutting edge way to enhance the diagnostic quality of low dose medical imaging, providing notable gains in image resolution and noise reduction without sacrificing the visibility of clinically critical features. This method will guarantee that the improved images maintain the clinical integrity required for a successful diagnosis, in addition to increasing the accuracy of disease identification. This discovery is significant because it has the potential to completely transform the clinical application of low dose medical imaging, meeting a pressing demand to improve image quality while reducing radiation exposure for patients. Modern medicine is increasingly using low dose imaging procedures like low dose CT scans and X rays to low radiation hazards to patients. The goal of this study is to create a deep learning based method that improves low dose medical image quality and resolution without sacrificing clinical integrity. For medical imaging to continue to be useful,
This is a
it
nine
must be.
minutes reminder.
Yes, ma'am, just winding up. Okay, let me jump to the problem statement. Here's my problem statement. Development of a deep learning model capable of generating high quality, high resolution images for the low dose images to improve the diagnostic accuracy by enhancing the visibility of clinically relevant features and enabling more precise detection of abnormalities. Now, from the above the survey, I have found out some objectives on which I would like to work on. Enhance image quality and resolution while preserving clinical integrity, and address inadequate improvement for subregions and focus on regions with low CNR. This is the model development, the flow of my research. To enhance the diagnostic quality of low dose medical imaging, we developed a robust image enhancement pipeline, which contains cycle GAN, super resolution GANs, then SWIN-R IR hybrid pipeline diffusion model. Here, super resolution GANs is used to increase image resolution and recover fine structural details critical for clinical implementation.
Ma'am,
Then
I
cycle
request you to kindly conclude as we have crossed the 10 minutes mark.
Okay, sure, ma'am. Okay, just jumping to the conclusion, just discussing the conclusion. Like currently modern medical image enhancement is shifting from visual improvement to preserving diagnostic accuracy. Advanced techniques reduce noise, avoid over enhancement, and support safer or more efficient clinical decision making, ultimately improving patient care. These are my references. Thank you so much. I conclude here, ma'am. Thank you so much.
Thank you, ma'am. Are there any questions?
No, ma'am, you can proceed for next.
All right. Thank you so much, ma'am.
Okay. Thank you so much, ma'am.
Moving forward, I would like to request Sir Vishal Shah to kindly present his paper titled Reconfigurable Intelligence Service.
Ma'am, my screen is visible to you.
Sir, just a second. Emerging trends and techniques shaping future for integrated sensing and communication. Not yet. Okay, yes. Your screen is visible. You may start.
Okay. My paper title is Reconfigurable Intelligence Surface, that emerging trends and techniques that shaping the future for integrated sensing and communication. Myself, Vishal Shah, and my guide is Dr. Rupesh Patel, and I'm a research scholar in EC department from CSPIT, Charuset University. So basically, as we know, as per the continuous new updation of that from 5G to 6G, we required continuous data updates, and just because of different problems, just to update the new technologies. Let's say as the frequency is continuously going on, that is from sub gigahertz to the terahertz. Let's say if it is we consider the millimeter wave, that is it is in the range from 30 to 300 gigahertz. And if it is in 6G, then it is continuously in process, like it is from zero point 0.1 terahertz to 10 terahertz. And particularly as per the new requirements, let's say to upgrade our technology, we require to have some particular trends that we require to update, like low cost. The device should be low cost, then the complex should be less. Then the next, according to the data rate, we require some high accuracy. Then the latency should be low. Then just because of some losses, we require to go beyond some connectivity. So that's why there is a new physical dimension we have that is continuously in upgradation and the standardization. That is about the reconfigurable intelligence surface. Basically, its uses for the beam forming and just whether it is used in the particular system in the application where the signal is not getting propagated. Let's say we consider in a long tunnel, specifically just because of some distortion, the signal processing cannot be done properly. So especially for the sensing and the accommodation purpose, this reconfigurable intelligence surface is good over there. That particular they are enabled to just demand the particular data rates as well as the good coverage, as well as with respect to
I
power
just
it gives
request you,
the.
please come on your part of work.
Yes, ma'am. Actually, my part is like basically the classification of reconfigurable intelligence surface. And in that reconfigurable intelligence surface, basically, it is a particular meta surface where we can control that particular beam by using a three method, that is phase, amplitude, and polarization. So, particular in that, with respect to the existing technology with our RIS, we can say that in the previous technology, we require to use some RF chain. That means the amplifier is over there. Just because of that, there is a very high loss. And if we use a RIS, then there is no use of that particular RF chain, or you can say that amplifier, just to propagate the signal as a reflection. Basically, if we consider the basic structure of that RIS, then the main features is like there is no requirement of any power amplifier. Then the second, they doesn't require any signal processing, and the main feature of that, it is a low energy consumption and the high spectral efficiency. If we consider the basic structure, because this paper is totally based on the classification, I have identified some different types of RIS over there based on the structure and their functions. So basically in the structure physical, because my PhD topic is just to design physical RIS. So in that particular RIS, basically it is a 3-layer we can bifurcate. The one is the mean meta surface, then the last one, that is the controller part. So that particular architecture, if we consider the first, where we integrate some pin diode or MEMS, or maybe in a real time, let's say up to 2030. In Japan, there is one company, they use a liquid crystal just to interface or to propagate the signal over there instead of that pin diode and uh, Varictor diode. Just because of in the pin diode and then Varictor diode, there is a limitation like up to terahertz. When we go beyond the terahertz, so at that time it is not functionable by using that particular component. So as I told you, there is these are the application. I have just represent this, the application of the RIS in a graphical form, where you can see we use the particular RIS in a smart office. That means the indoor application as well as the outdoor applications. As we identify, we can say you can operate this RIS, or you can design the particular RIS for the different modes. Like the one is you can use the particular RIS only for the reflection, just to improve the coverage. Then second, you can use as a refraction. The third one you can use as an absorber, like in a solar panel, we can use RIS. That means the dual function are there, where you can use the absorptive as well as the reflective. Then the second is you can use a particular as a specific in a, let's say particular as a network controlled RIS. You can use it as a transmitting and receiving RIS. So this is the main part from my side. By referring that near about 30 papers, I have just identified the different types of RIS we can classify it. First one, that is based on the hardware design, where you can classify into 3 types, whether your RIS is active, passive, or hybrid. The second, by using continuous and the discrete phase control, you can design the particular RIS by using Varictor, PIN or MEMS. By using Varictor, you can get the continuous phase shift, but in a pin diode you can get a discrete phase shift, like a specific phase shift, like on a 30-degree, 60-degree, 45-degree, like this. The second one, that is like based on the different functions, you can classify the particular RIS. Like you can classify on a specific functions, or you can design the particular RIS for the dual or more than 2 functions. Like say star RIS, where the transmission and the reflection both are come into the picture. That means the RIS capable to do both the things. The next is like based on the controlling type of RIS, basically it is a user side, or it may be at a network side, or it may be a third party is involved, like a network assisted RIS. Or you can design the particular RIS for the specific applications, where it is like under the category of standalone RIS. Then the next type is like based on the deployment. That means you can fix it for the specific application. Let's say in the previous slides, I give the example for the indoor, you can use a static RIS, but when you require to use a mobile, let's say for the vehicular communication, where you require to continuously beam forming is required. So at that time, you can fit these RIS into the any mobile device. The third one, that is nomadic. That means you can integrate it for the static as well as the autonomous. Like you can integrate as a personal, or it may be a user, or it may be on the vehicle. And the last, that is about like this is the scattering matrix. That means the basic theory. Based on the basic theory, how you can modify the phase over there, whether it is only a single element or it is a more than one cell. So based on that, you can classify it like whether it is a diagonal or it is a non-diagonal. Currently, that is written with the short name like BDRIS. That BDRIS nothing but like a non-diagonal matrix based RIS. So these are the different detailed explanation for that each and every types. Like you here, you can see in the active RIS, we require some active elements, let's say amplifier, but in passive RIS, we doesn't require any amplifier over there. But nowadays, we refer some paper. I have refer some paper, and I have identified like in some portion they use active component, and in some portion they don't require. And that means the hybrid, that is a combination of active and passive RIS. Now, as I told you in a previous slide, like in a continuous and discrete RIS, some RIS is referred with pin diode and some is designed with Varictor. and some is designed with the MEMS based component they use. So basically, in this comparison, I have identified like if you require to go beyond the like 24 gigahertz, so at that time this pin diode and varactor diode is not we cannot able to use. So over there, compulsory we require to go with the liquid crystal. So for the high frequency, there are two options we have. Whether you require to switch with MEMS, that means the specific switch we have to design, or you can go with the liquid crystal. And in comparison with all these three, varactor diode is somewhat good because it gives the continuous phase shift and it gives the precise tuning instead of pin diode. Because in pin diode there is a limitation, like if you 1 bit, 2 bit, or 3 bit, you cannot able to. But in varactor diode there is a modification. Now, as per the function I told you, like different RIS you can classify with as per the functions. Maybe it is a single or it may be a multiple. Like in the control logic, as per the classification of control logic, it may be classified into the four category.
This is
Like
a
it
9
may be
minutes reminder.
okay. So let me reach to the scattering based matrix. So in this, basically, the portion is like I'm just wait a minute. This is the main part that I have identified. Like most of the each and every RIS is designed by the diagonal matrix, and the hardware is available, but very one or two hardwares are available that is based on this like BD RIS. So it may be a single connected or it may be a group wise connected. So based on this hybrid mode, you can include more function in the single RIS. So this is the main important part, and that's why it is with new classification that is like BD RIS. Now, by referring all the papers and especially I have identified some problem during the designing of RIS. Like the first, that is the most important part is like cost, and the second part is the like scalability. So as a solution, like we require to design the RIS in such a way where it should be low cost. With respect to steering coverage, as I told you, if it is below 20
Sir,
gigahertz, then it is
I'm sorry, but I request you to kindly conclude as you have
yes.
crossed the 10-minute mark.
Okay. So in that particular, the conclusion from my side is like if you require only the limited function, then you can refer a passive RIS. But if you have a more than one function, then you can go with the hybrid RIS where the active and passive both the components are used. These are my key references that I have used just to identify this classification. Thank you.
Thank you, sir.
Okay, Vishal, as I discussed you earlier,
Yes.
which sort of your work? Because as you discuss RIS, 5G, 6G, all these, the classification and comparison you are doing in your paper.
Ma'am, I have referred that all the papers, review papers over there, but each and every review
How many
papers,
papers you are reviewing?
33 papers, ma'am.
33 paper.
Yes,
Only
ma'am.
33 papers can be differentiate the two basic technologies like 5G and 6G.
No, I'm targeting, ma'am, only this component that is only targeting this reconfigurable intelligent surface.
Okay, only RIS you are
Yes,
taking.
only on RIS, and the each and every paper where few 5 to 6 papers are the review papers, and most of each and every paper in each and every paper they have worked with the channel. That means only the software MATLAB part is there. That means like the channel coding and there, and they design one code book. So only the software part, but they directly assume that it is a 1 or 0, but they don't work with beyond 0 and beyond 1. That means between 0 and 1, if there is some signal, then they cannot able to work
Yeah,
like.
okay, fine. It is these are the signals. Have you
Yes,
add these all papers in your reference? Can you show
yes,
me?
yes, yes, ma'am. These are the key references that I have considered.
Okay, which one is your as work as a base paper?
First one, ma'am, the review paper on hardware. Because in the last third slide, that is a totally hardware based, where I identify like if you require to go beyond the 20 gigahertz, then at that time you cannot able to use vector or that. A specific RFIC we require to design. It may be SPDT or it may be DPDT.
Okay, fine. Thank you.
Okay.
Thank you, sir. With this, we have come to the conclusion of this session. I sincerely thank all the authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 10th version and all the previous 9 versions of the conference. We will be happy to have you in the 11th version in 2026 as well. All the presenters would be getting their digital certificates through email within 2 working days. The publication will be live within 7 to 8 months. Kindly cooperate with the team of ICTCS 2025. I would also like to thank our session chair, Dr. Bindya Jain, for chairing this session. Has a small token of appreciation from the team of ICTCS 2025 and Global Knowledge Research Foundation and partners. Thank you for joining us, ma'am, and thank you to everyone for your valuable presence. With this, I would like to conclude the session. Um, Ma'am, if you would like to add any closing remarks before I do an official conclusion.
No, ma'am, it will be very nice session. All the presentation are very nice. Uh, so thank you so much.
Thank you so much, ma'am. Before we end, I would request everyone to kindly turn on their cameras so that I can take a quick snapshot and we can end the session. All right. 1, 2, 3. Thank you so much, everyone. Have a good day. Bye bye.